When you press a button on a standard household remote, it floods the surrounding air with a dense, invisible burst of radio waves. Today, we are going to intercept these uninterpreted radio signals and convert the raw data into a structured digital command. To do this, you need 4 specific things: a Flipper Zero, a simple sub-GHz target device like a wireless doorbell remote, a standard USB cable, and the Flipper application installed on your PC. Establishing this capture protocol reveals the underlying logic of wireless communication. It creates a technical foundation for auditing hardware security. Before we can record anything, we have to find the exact frequency the remote uses. If you skip this and guess the frequency, your device will only record environmental static. Grab your Flipper Zero, navigate to the sub-GHz menu, and open the Frequency Analyzer tool. Place your target remote directly next to the Flipper Zero and hold down the transmit button. You will see a prominent frequency spike appear on the Flipper's screen. Note the exact megahertz value displayed at the peak of that spike. Locking in this specific value acts as a precise filter. It allows you to isolate the targeted data transmission from the constant hum of background noise. Back out to the main sub-GHz menu and launch the Read Raw application. Press the left button to access the configuration settings and manually adjust the frequency to match the exact megahertz value you just found. Next, set the modulation parameter to AM650. Most basic household remotes rely on amplitude modulation to communicate. Specifically, they use a method called on-off keying, or OOK. This means the remote encodes its data by aggressively chopping a continuous carrier wave into distinct blocks of signal and gaps of silence. With the Flipper configured, press the center button to initiate the capture. Then, press the button on your target remote to emit the signal. Now, look at the Flipper's RSSI diagram. You should see vertical lines populating the screen, confirming the device is actively registering signal strength. Stop the recording process. Save the file directly to the device's SD card and give it a clearly identifiable name. You have now trapped a fleeting, invisible radio transmission and locked it into a permanent digital file on your hardware. To analyze what we actually caught, we need to move to a digital environment. Plug your Flipper Zero into your PC using the standard USB cable. Open the Flipper desktop application. Navigate to the File Manager, select your SD card, and open the folder labeled sub-GHz. Locate the specific .sub file you just named and download it directly to your computer desktop. If you open this file in a standard text editor, you will see a massive wall of raw microsecond timing data. Parsing these numbers by hand is inefficient, which is why we rely on automated visual tools. Open your web browser and navigate to the Flipper Lab Pulse Plotter tool. Take your extracted file from the desktop, drag it into the browser window, and drop it. The software will automatically process the data. This chart is the visual timeline. The software translated thousands of microsecond values into a precise map of radio pulses. High green blocks represent active pulses, flat red lines represent gaps of silence. This is on-off keying mapped out perfectly. Scroll down to the bits output section at the bottom of the plotter. Here, the tool interprets the pattern of those pulses and gaps and outputs the final translation in hexadecimal formatting, revealing values like 00, 7D, 05. By converting time-based radio bursts into a structured hexadecimal sequence, you have successfully extracted the exact digital password the remote transmits to communicate. You started with an invisible environmental transmission, mapped out its exact microsecond timings, and decoded its core payload. You can apply this exact analysis framework to audit other static code household systems, like ceiling fans, remote weather stations, and basic wireless alarms, all use similar protocols. However, this method has a strict limitation. High-security systems, like modern garage door openers, utilize rolling codes. Their digital payload changes upon every single press, specifically to prevent this kind of simple replay attack. Mastering this static, raw capture process provides the baseline. You must understand how these simple protocols behave before you can begin to analyze or eventually compromise dynamic cryptographic radio systems.